Nowadays everyone's a consumer of AI, whether you use Google search engine or you use an autonomous Tesla car or whether you use an app on your mobile phone and Facebook. And it's important to design this AI in a way that respects the kind of boundaries we've set in our society for how people should live peacefully and efficiently. Designing these sorts of algorithms and platforms and systems is quite challenging if we do not bring together the right people to work together on this. And the Center for Machine Intelligence is exactly about doing that. It's about bringing researchers, academics, people from industry, policymakers, and the end users to work together to address real significant challenges in society.
So one of the things we're trying to do is to use models from epidemiology on mobile phone data, interaction data, to try to improve the predictive performance of epidemics. So for example, if you consider the epidemic spread of cholera in a country, we can use models from epidemiology and apply them to interaction networks obtained by large-scale mobile phone data sets. So we can try to predict how quickly the epidemic might spread.
So a good example of how we're using computer vision and machine learning is in the work that I'm doing with Ordnance Survey. I'm working on building machines that learn to see. For example, cars on the roads, knowing where the cars are, knowing where the traffic jams are. Government organisations like DEFRA would like to know which bits of land are being used for grazing at various times of year. Trampolines on housing estates can tell us whether there's a lot of children there, for example. However, there are still big issues that need to be considered. You know, if you build a building in your back garden, you haven't got planning permission for it, this data potentially could be used to detect that. There's a whole raft of legal issues around this space.
We've sort of opened a Pandora's box that may be very difficult to close, and we've seen the problems with the internet. AI is even more problematic than that. If we are going to evolve machines that can think, make intelligent decisions, we need to do it in such a way that those decisions are good for society.
One of the key goals of the Centre is to bring together academics, lawmakers, policymakers to really think hard about how do we design machine intelligence that is responsible, that serves the needs of the greater society rather than just a company that designs them for pure profit making.
We have a project jointly funded by EPSRC and their Singaporean counterpart on smart traffic control, making smart traffic control more secure. If you can hijack the system, then you can create chaos. So with game theory, we are able to understand and model potential attack threats within the system, and then we use machine learning to focus on those areas and then detect whether there are any suspicious behaviors.
I'm looking at ways in which we can use AI techniques to help make good decisions in responding to emergency situations. What we do is we use argumentation-based reasoning in order to compute all the alternative hypotheses given the prevailing circumstance. So we can use data from social media, we can use imagery data, we can use speech even. Once we've computed the alternative hypotheses, these can be visualized by the expert so they can get an understanding of what the alternative hypotheses are, but also where the uncertainty lies, enabling experts to respond more rapidly to evolving situations and produce decisions more reliably.
One of the applications that I'm working on is applying machine learning to try to predict early Parkinson's disease, and we're doing this by measuring people's typing habits on a keyboard. We actually are able to predict Parkinson's versus non-Parkinson's by just considering the whole time of the individual keys that are pressed.
If we look at the ideal AI system in the future, I would imagine something like a little child that can, with small amounts of information, make very complex inferences and very quickly learn things, just like a child learns a new language. But seeing the discrepancy between what an organism can do, so if I have a small circuit here in my hand, and I would have a cockroach in my hand, then I see how inadequate is what we currently can build. And that big gap that inspires me to look at biology and say, what are the tricks which are used there? How can they achieve that? And maybe I can transfer a little bit over.
Okay, so this is a multi-legged robot, so it has 6 legs, right? And it can move around, right? So it can crawl about like a six-legged insect, you could imagine. So the kind of questions that we're trying to address are, how can you teach these robots to learn to walk? But also, when it gets damaged, how can they adapt very quickly? So maybe in just a few minutes, instead of hours, which is the state of the art, to these kind of damages. So currently robots that are out in the field are usually teleoperated. They need constant human supervision, right? So if robots could actually do these kind of adaptations on their own and very rapidly in dynamic environments, then we kind of increase the autonomy of these robotic systems. So we can allow them to operate for long periods of time. And then you could imagine a lot of applications for example, for robot swarms, which have to like cover a very large field, like in precision agriculture.
We all have great hopes for AI and its impact on society, but we really need to make sure the systems we develop seek to protect people's privacy and their security, and to watch for the areas where it could all go horribly wrong.
Intelligence, AI, machine learning and autonomous systems will do things better than humans in many ways, and we'll take this for granted. And when that starts happening, there are really difficult questions that we'll have to ask about how we learn, how we entertain ourselves, how we care for each other. In the longer term, we see this center as bringing in additional funding, additional resources from a number of different sources, and really build critical capability that can deliver on very, very specific agendas from the government and from industry.